Hello class, welcome to week 7 of Python. So this week we kind of went over functions. Functions kind of allow us to create pieces of code that can be reused multiple times so that we don't have to create like a series of print statements, because at that point it just becomes really repetitive and can kind of feel like a waste of time sometimes. So that's kind of the purpose of functions. So I am going to kind of go through it piece by piece. So we're going to start off with defining a function. So on the left hand side you guys can see that an example of function definition. The function definition just kind of means um, how do you define the function. So like you start off with def. So def, just it's a piece of the syntax that's always going to be used, so that part is never going to change. You're always going to start off your functions with def. You're going to follow that with a space, and then after that you're going to include whatever you want to name the function. In this case they have function underscore name. It can be something like we have over here. It can be like directions to Times Square. Name it whatever you want. Just make sure that there's no spaces in between the name. So if you do want to separate words within the name of the function, you're gonna have to use underscores. So just like here, directions underscore to underscore Times Square. Um, so just make sure you don't leave spaces in your function name. And then after the function name, you always end it with not parameters, parentheses, and inside the parentheses you have the option to include parameters. So we're going to get into parameters in a later slide. Right now, just know that you always include parentheses, the open and closed parentheses, and then you follow that with a solid colon. And that's kind of how you define a function. Now within the function body, it's kind of the same way we've used other pieces of code. You want to indent the function body. So like as you guys can see here, we have the name of the function up here, def, and then whatever you want to name the function. And then inside they indented their cursor so that the first print statement is indented to def. That tells Python that everything here belongs to the function of def directions to Times Square. So when Python is trying to execute codes, because we don't use curly brackets in Python like we use in other programming languages, Python identifies certain blocks of code by the level of indentation of the line of code. So all of this belongs to def directions, but over here, um, actually this should be outdented. Yeah, okay, so over here, when I'm calling the function, so like when you call a function, you just state the name of the function. So you don't have to include the def, you just the name of the function with its parentheses. And then in this case, if it had parameters, I would put something in here, but I'm getting ahead of myself. So for now, just know that to call a function, you just rewrite the name of the function with parentheses. And when you do that, what that's essentially doing is Python saying, okay, you want me to execute the body of this function. And what's in the body of the function? All of these print statements. So that's why when I ran that piece of code, it printed out 3 print statements. And those 3 print statements belong to the function of directions to Times Square. So that's kind of like the base of functions. So here they just kind of tell you include the def keyword, make sure you include your parentheses after the function name, the colon, and then the body. That's all they're kind of going over here. Let's move on to the next slide. So the next slide is the calling of a function. I kind of already went through that, but I'll go through it again. If I define my function and give that function code to execute, when I call the function, I have to make sure I don't I don't write it at the same indentation level as the function itself. Because if I do that, when I run this code, nothing's going to happen. Because Python's going to think this line of code belongs to the function. So when the function sees that, because I'm not printing it out, nothing's coming out. Even though these are print statements, they're not actually being executed. They're only executed when you call the function. And you can't call the function within the function, which is why this doesn't work. You have to call the function outside of the function. So to do that, make sure you write this at the same level as def, which tells Python that, okay, this is one block of code, this is another block of code. Even though this is one line, because it's at the same indentation level as the function def, Python reads this as separate lines of codes, separate blocks of codes. So, like I said previously, when you call the function, you have to give Python the full name of the function. You don't have to include def. You have to include the parentheses, and right now they're not showing arguments being passed, but if there were parameters, so like parameters are kind of like, think of them as variables that we're putting inside of these parentheses. I'm actually going to move on to the next slide because this slide we basically already covered. So white space and execution flow. I'll get to parameters in a second. So let me just go through this slide. So white space and execution flow. This is basically just telling you make sure you indent properly. And so, okay. On the left hand side right here, we have the function of trip welcome. And trip welcome includes two print statements, right? So I defined this function. I gave the function a body, in this case two print statements. After that function, here they unindented a line of code, which means it no longer belongs to the function of trip welcome. It's just a regular print statement, and this print statement is going to print out this string, and then after that print statement they called the function of trip welcome. So what's going to happen here, Python's going to execute code from the top, starting at the top all the way to the bottom. So Python doesn't execute this function of trip welcome because right here all we're doing is defining the function. So it's like giving the function, it's like giving Python a set of rules, but we're not telling Python to use it yet. We're just saying, Python, here's a set of rules. When I tell you to use it, but don't use it yet. And then after that, after we told Python to do that, we gave Python a print statement, just a regular print statement. So what Python's going to do is Python's going to say, okay, I have your set of rules, you don't want me to use it yet, but you're giving me this print statement, so I have to print it out because it's a solo print statement. It doesn't belong to the function that you gave me. It's just a solo print statement, so I'm going to print that out first, and then after that, I'm going to print out the function because you told me after the fact to print out the function of trip welcome. So that's why Python kind of, it's always going to execute from top to bottom. It's never going to, it's not going to skip this print statement. It's going to print that out first, and then it's going to print out trip welcome, which is going to print out these two print statements that belong to trip welcome. So that's kind of why we get the outcome of, whoa, look at the weather outside, don't walk, take the train, and then we get the trip welcome print statements after the fact. So that's kind of what this slide is going over. It's just reminding you the importance of indentation when dealing with functions and just dealing with anything in Python. And we can go to the next slide. Okay, we're finally at parameters. So as you guys know, when we declare a function, we have to include parentheses. So within the parentheses, we have the option to either include parameters or not. So parameters, think of them as either variables that are specific to that function. So like when you kind of create a parameter in a function, it can be used within the body of the function, but it cannot be referenced in a different body of your code. So like if I define the parameter of location for the function of generate trip instructions right here, say I had um, another body of code and I want to use a for loop or like any kind of loop, um, and I want to use that same parameter of location or variable location, Python is not going to allow you to use that variable across different bodies of code. It's it's only allowed to be used in the function body. So just keep that in mind. But parameters are kind of used as placeholders. So when I define the function of generate trip instructions and I include the parameter of location, location is really just kind of a placeholder that when I do call the function at a later time, because remember we can call functions outside of the function itself, the placeholder will take in a value. In this case, on the right hand side here, we have the parameter of location for this function, and when I called the function, I included the argument. So when you give a parameter a value, it's called giving a parameter an argument. In this case, I gave it the argument of Grand Central Station, which is a string. So when this code does run, it's going to print out the print statements, the body of the function, which are two strings. The first string looks like you are planning a trip to visit, and then in the function I just wrote location because I don't know what location I want to include in the string um, at the time that I was writing the function. After the fact, I decided I want to give location the value of Grand Central Station, which is why I said think of location as a variable, because a variable really is just a placeholder, and then like say when you assign a variable a value, then that placeholder kind of represents the value, which can either be a string, it can be a number like an integer, it can be a decimal value, it can be a Boolean value, it could be whatever. That's kind of the flexibility that functions give you. It allows you to write these print statements or like mathematical equations inside the body of the function, and instead of using actual values, you can just put placeholders. So that way, in this case, I put Grand Central Station. If I wanted to change that to something else, I could. And it doesn't force me to write this whole string over again. It's still going to write the looks like you are planning a trip to visit, and then it's going to stop there. And then whatever I want to include after that, I can swap out whatever name of location that I want. That's kind of the flexibility that functions give you. They don't force you to rewrite the whole string, it just allows you to change a specific part of your string. In this case, it's a string. In other cases, it could be uh, like values for mathematical equations. So, like, say I wanted a function to generate like the square root of certain numbers, like 5. Or no, say I wanted it to give me the exponential value of like 5 to the whatever power. Maybe in one case I would want to take 5 to the second power, but then say I want to change that power to the 10th power. I could also do that. And you do that with these parameters. So in this case I only have one parameter. Say I wanted multiple parameters, we will get into that, but right now they just kind of they're dealing with one parameters, they're kind of introducing the topic to you. So just remember, I went off on a little tangent, but just remember that when you define the function and then you include these parentheses, anything that goes inside these parentheses is called a parameter. So it's a placeholder, it's a variable. It has no value yet. It's just there to represent a placeholder for whatever value you want to give it later on. when you call the function, which is outside of the function, when you call the function, you give the name of the function, you put the parentheses, and inside of that, you can give it a string value, you can give it an integer value. This is called an argument. This will take the place of your parameter. So at the very base form, that's what it is. They kind of give you the, so they kind of break it down here. So if you are going to include the parameter inside of your print statements, as we've always done it, like in this case, this is called parameter, but when we've included like variables in our print statement in prior weeks, we always have to separate them with the plus operator, because when you have a string value and then you have a variable value, um, they're not the same data type. So when you print them out, you have to separate them with a plus operator, so you just include a plus in between them, and that way Python recognizes, okay, this is the string, it stops here, and then you want me to include a variable or a parameter after it. So just remember to do that. And that's kind of all this slide is really saying. So let's move on to the next one. So multiple parameters. So this is kind of what I was talking about. So here, notice we have the function of def calculate expenses. Inside the parentheses, we have 4 parameters. We have plane ticket price, we have car rental rate, hotel rate, and trip time. Now, within the function, instead of having print statements, which we've seen thus far, just print statements, we have actual mathematical equations, which is what I was referencing in the previous slide. So you don't only have to have print statements inside of functions, you could do like mathematical equations, because that kind of like, that's another purpose that functions serve. Sometimes like the values of the numbers change, but the equations do not change. So say I wanted to get the total of like car rental. So car rental total would be, it'd be equal to car rental rate times trip time. So that equation will never change, but the numbers may change. So that's kind of the purpose of parameters. Parameters will hold the place within the equation, and then when we call them, we enter in values that pertain to each parameter. So in this case, when I have 4, well, I guess another question you might have is, okay, I have 4 parameters here, I have 4 arguments here, but where do they go? Like, does 200 take the place of trip time? Does 100 take the place of plane ticket price? No. Okay, so they're gonna sequentially take each place. So plane ticket price, when I pass my first argument, which is 200, it's gonna take the first parameter. So 200 will take plane ticket price, 100 will take car rental rate, the second 100 will take hotel rate, and then 5 will take trip time. And this is kind of referred to as, let me see if they have the name of it. Actually, let me open up the PowerPoint, because there is a specific name that they use to reference this one-to-one assignment of arguments to parameters. So just give me 1 second while I pull that up. Okay, so let me share this with you guys. Alright, so multiple parameters, calling a function, local variables, global variables. Is this it? No, it's not it. User defined functions, function parameter. Perhaps I did not include it here. Okay, I'll close that for now. Well, I believe it was in your textbook then, because there was a specific name that they gave to reference the one-to-one relationship between the first argument with the first parameter, the second argument with the second parameter, but I guess they don't include the name here, which is a little bit funny, but it's okay. So let's move on to the next. Okay, here it was on the next slide. Okay. So types of arguments. So you have positional arguments, which is what I was referring to in the previous slide. The first argument will take the first parameter, the second argument will take the second parameter. It's called positional arguments. The second one is keyword arguments. So keyword arguments, let's see if they have an example of it. Okay, so here we have the example of keyword arguments. So say we had the parameters of rate, discount, and miles to travel, as we do up. So yeah, say it was up here, right? And when I called the function, I called the name of the function, and then inside the parentheses, instead of just giving the value of the parentheses, or of the instead of giving a value for each parameter, like in order, I can mix up the parameter order in the parentheses as long as I state the parameter name and then do equal to whatever value I want to give it. So like, let me write it out. So say this is fine. Yeah, say it's first destination. The function is trip planner, and I have three parameters, right? Okay, now I'm gonna call trip planner, and inside of it, I want to do second destination equals Brooklyn. The third one is gonna be final destination equals Queens, and the last one's going to be first destination equals, what am I missing? Bronx. Okay. So this would be an example of a keyword argument. So when I called each argument inside of trip planner, I didn't do it in the same order that it shows up here. So up here we have first destination, but down here I have second destination as my first argument. So what's going to happen is, because I stated the name of each parameter, Python says, okay, even though it's not in order, I know which value belongs to each parameter. So I can still assign it, so if I ran this code, it's going to work. So it's still going to assign the correct values to each parameter. It's a little bit more work, but it gives you the flexibility of not having to make sure that you write each argument in the correct order. It allows you to mess up the order as long as you provide the parameter name and then equal it to whatever value you want to give it to. So it's just another way of writing arguments. It's called keyword arguments. The final thing is the final thing is the default arguments, which is arguments that are given default values. So I had an example up here, but I messed it up. But there's another example down here, I believe. Let me see if I could find it. Okay, so this is an example. It's called def calculate taxi price, and then inside of it I have three parameters, right? But if you notice, when I'm defining this function, I included two parameters. As you've seen before, they don't have any values yet, but this third parameter does have a value. And it's a little bit weird because we haven't seen this yet, but this third parameter is being equated a value of 10. Why is it being given a value? What's the point of giving a parameter a value? Because I thought parameters were supposed to be placeholders so that values can be placed into them later. True, that is the purpose of parameters, but in this case, this is kind of called a default argument. So like the parameter discount is given a value of 10 by default. But not by default. We're giving it the value of 10 so that it can default to that value if we don't assign an argument to the parameter of discount. So that sounds a little bit confusing, but let me show you. So yes, we define this function of calculate taxi price. When I'm calling taxi price here, I am only passing two arguments, the value of 10 and the value of 0.5. So as we know from positional arguments up here, it's a one-to-one relationship. So the first argument of 10 will go to the first parameter of miles to travel. The second argument of 0.5 will go to the second parameter of rate. And we don't have a third argument, even though there's a third parameter. So what's going to happen? When I run this code, is Python just going to error out? No. Because when we originally defined the function, we gave it a value of 10. So Python's going to see this and say, okay, even though you didn't give me a third argument, because whoever created this function originally gave that third parameter a value, I'm going to use that value when you call my function. So when I call this function, it's going to print out this. It's going to do miles to travel, which we know is 10, times rate. So it's going to do 10 times 0.5, and then it's going to subtract 10, because it's going to default the value of discount to 10. And that's essentially the default argument. Now, just because we originally assigned a value to this third parameter of discount, the value of 10, does not mean discount can never have a different value. So we can also overwrite the default value by including a third argument when we call the function. So another example down here, we have calculate taxi price, the name of the function we're calling, and we have the same first argument of 10, which is going to take the first parameter of miles to travel. We have 0.5, which will take the second parameter of rate, but we do have a third argument here of 20. So even though originally discount is equal to 10, when Python processes this call of the function of calculate taxi price, it's going to take this 20 and replace 10 with 20, and essentially overwriting the value of discount, which is fine. So if I were to call this function again a third time, and I just included two arguments, it's still going to default to discount 10. It's just for this specific call that I overwrote the parameter value of 10. But it's like specific to that call. If I were to call it again, it would still default to 10. So just keep that in mind. So I'm going to move on to the next slide. So built-in functions versus user-defined functions. So every function we've gone through thus far are called user-defined functions, because we're giving the function a name of our choosing, and we're giving it a body of code to execute of our choosing. So that's why it's a user-defined function. Now there are built-in functions. In a built-in function, we've kind of already used them before. So examples of built-in functions are print statements, or like the length built-in function. So like if I wanted to know a length of a list or of like a string, we've kind of already used that before in previous homework assignments. But len, open parenthesis, close parenthesis, and then you put a variable inside of it, that's technically a built-in function. So here they're just trying to tell you the difference between the two. Even though they both have the word function in them, they are different. So they just want to kind of make you aware of that fact. So let's move on to the next slide. So variable access. I did briefly go over this at the beginning of the video. So if I were to call the variable of, so hold on, destination, scope, okay, yeah. So variable access, okay. We have the function of def trip welcome. So the function's name is actually trip welcome. Inside of it, I have the parameter of destination. In the body of the function, I can call that parameter in my code, and Python will recognize it as a variable, but it's a local variable, and a local variable means that it is only locally available to that function. When I write code outside of that function and I try to reference that same variable, Python is not going to know that that variable exists because it's only locally recognized, it's not globally recognized. So there is a difference. So they do have an example here. So def trip welcome, inside of the parentheses of the function, I have the parameter of destination. I'm using destination within the code of that function, and I know that it belongs to that function because there's an indentation right here. Now, I have another line of code, another print statement, but notice that it's not indented, and because it's not indented, it means that it does not belong to this function of trip welcome. It's just a regular old print statement. And inside that print statement, I'm attempting to print out the whatever value is assigned to the variable of destination. And when Python sees this, it's going to output this. Name error, destination is not defined, and what it means by that is that the variable destination was never originally initialized. So like I never basically, it's saying that I never gave a data type for destination, and I never told Python that destination is a part of my code. And more so, I never gave a value to destination. So it's like destination doesn't exist yet, and I'm trying to call something that does not exist. So even though it does exist inside of the function of trip welcome, it's isolated to only that function. So that's kind of like what the slide is saying. Variable access can be a little bit tricky with functions. Functions are a little bit isolated in that respect. If you're going to call a variable inside of a function, it belongs to that function only. You can't call it outside of that function. Now, if they do have another example here where I am calling a variable budget, I'm giving it a value of 1000, and I am kind of referencing uh, that variable inside of my function of trip welcome. So on my second print statement, I have your budget for this trip is, and then str budget, so the str function, and then I'm including budget inside of it, which is fine. And then outside, so I unindented this last print statement, I'm calling budget again. And the reason it works is because budget is a global variable in this case. The global variable means I defined it outside of the function, so the program recognizes that variable budget all across the program. It can be used in its global scope. It can be used within certain blocks of code. So like in this case, it could be used in the block of code that is a function. It could be used anywhere. The difference between it is that I declared it in its global scope, and then over here I declared it in its local scope. So there is a difference, local versus global. So do try to keep that in mind when you are dealing with functions. If you do run into this error, it could be that you're trying to reference a local variable that hasn't been defined globally yet. So that's that. Let's move on to returns. So returns is like a way of telling a function um, to do something, but not necessarily print it out to the user. So if I have two parameters of US dollars and exchange rate, those parameters are going to be used, just from the names I can tell, they're probably going to be given a numerical value. So I'm probably going to do a mathematical equation with them. So as we can see in the return line, this return line belongs to the function of calculate exchange USD, and I know that because it's indented. I can see that US dollars is being multiplied by exchange rate. So there's like a mathematical um, uh, equation going on there. So instead of writing print and then putting this equation in a set of parentheses, I want to return it. And by returning it, what I'm essentially doing is I am saving that value in that function so that it can be used later on. And a print statement, in contrary to return, a print statement doesn't necessarily save the value. What it does is when Python executes a print statement, it immediately prints it to the console so that the user can see the result. It doesn't memorize what's happening there. It just does it. So a return statement will save the the output and not necessarily print it. So I guess that's kind of like the easiest way to explain it. So right here, um, write your code. So I have a variable of shirt expense. It's 9. I gave it a value of 9. So that is my global variable. Then I have a function. I have a deduct expense function with two parameters, budget and expense, and within this function I have a return statement. I am trying to tell the function return budget minus expense. Now we don't know what the value of either of those are, they're just kind of placeholders for now. And then below that, I outdented this next line. So by outdenting, I mean it no longer belongs to the function of deduct expense, it's its own thing. And this line is a new variable. This new variable is going to represent the new budget after shirt. So this new variable has a value of deduct expense, and you could say, okay, well, we haven't kind of seen that yet. Every time we've printed out or every time we've called a function, we've kind of just called the function and that was it. But here we're kind of using the function as sort of like a variable, um, in the same sense, because we're doing mathematical equations with this. So what this is really doing is it's assigning new budget after shirt, the variable of new budget after shirt, uh, to a value of deduct expense, and then times current budget and shirt expense, which is a little bit weird. um, we know current budget has a value of 3,500. We also know shirt expense has a value of 9. And deduct expense is just budget minus expense. Um, so when this does do that, like when it does calculate, if we run it, we have your remaining budget is 3,500, which is this function up here. And then we have your remaining budget is 3,491, which is this. So while the numbers may be a little bit confusing to you, just know that the whole point of return statements here is that it's not necessarily returning a value to me, it's saving data to Python so that I can use it later to calculate mathematical like equations. In this case, it was my new budget after I purchased the shirt. So that's kind of the purpose of return versus print. Um, let's go to next. So this is multiple returns. Multiple returns is uh, relatively similar. It uses the same concept, so I'm not going to really go over this. I do think I included it in the PowerPoint slide, so you could read through that. So sometimes we may want to return more than one value. We could return several values by separating them with commas. So yeah, that's kind of it. So like say I had, um, like right here, I have 1, 2, 3, 4, 5. I have 5 parameters for this global variable. Within the function, I have one parameter, which is weather. Now, inside of the body of the function, I am calling uh, three local variables of first day, second day, third day. And each of these variables are being assigned a value of a string. And at the end of the string, I'm including the parameter of weather, but I am giving it an index of 0, 1, and 2. So what is that doing? It's basically saying, okay, weather, which is this up here, weather data, this list of weather data, but give me the first index of the list. And we know from list indexes, which we went over in a previous week, the index of 0 would be sunny. The index of 1 would be sunny, or would also be sunny. The index of 2 would be cloudy. So when I do print this out, um, actually right after this I have return first day, second day, third day, and so it's multiple returns. You're just separating them with commas. I'm saying Python return the variable first day, the variable second day, the variable third day. So what Python's going to do is it's going to print out this essentially. It's going to print out tomorrow the weather will be sunny, because sunny is weather index 0, which is up here. The following day it will be sunny, because sunny, or second day, is equal to this string, the list of weather index 1, which is sunny. And then 2 days from now it will be cloudy, because the third variable that we're returning is third day equals to this string, referencing the weather list up here, but index 2, which we know is 0, 1, 2, which is cloudy. That's all it's doing. Um, and, and yeah, that's return multiple returns. And then the final slide is the review slide, which is basically just kind of going over everything I just explained. But that's it. That's functions. Not too complicated. It's just really knowing about returns. Returns are pretty important. Understanding variable access, knowing the difference between a globally available variable versus a locally available variable. Understanding the difference between a user-defined function and a built-in function. This is a little bit less important. Just knowing that we've used print statements, we've used length, we've used a bunch of other functions. Those are built-in functions. User-defined functions are kind of what we're doing right now when we do def, and then we give a function whatever name we want with its parentheses. Um, Types of arguments. Remember, are only used when we call the function, not when we write the function. So writing the function is right here, calling the function is this. So they're different. So just keep that in mind. So arguments are all of these things that are within the parentheses. In this case, this specific piece of line of code is a keyword argument. So keyword argument is when you have the parameter name equated to whatever value you want to give it to, and that value is your argument. There's three different ways of writing arguments, but just know that arguments are included when you call the function. So multiple parameters. So parameters, so remember, this is the call of the function. This is the actual definition of the function. So when I say parameters, I mean everything that is in the parentheses of the definition of the function. So def, whatever you want to call the function, and then you include your parentheses, and everything inside of here is the parameter. You don't have to include parameters in your functions, but if you do, you have to separate them with commas if you include multiple parameters. If you have one parameter, you don't have to include any commas, you just write that one parameter's name, and that parameter will be able to be used within the body of that specific function, not outside of it, only within that function. And then this is just telling you, remember about indentation, because that's pretty important. And then calling a function, we've kind of went over that many times. And definition of a function, it's just telling you how to write this very first line. It's always the same way. It always starts with def, followed by whatever you want to call the function, and then a set of parentheses. And that's it. That is functions. So that is week 7. I hope this was helpful for you guys. I just wanted to provide a breakdown of the PowerPoint, of the topic in general of functions, so that in case you guys are struggling with the topic, hopefully this video was a little bit helpful in explaining it in a more simplified manner. So that's week 7. We have spring break next week, so we won't have any homeworks, we won't have any YouTube videos or chapter reading, so you guys do have the week off. The following week we'll continue with the week, I called it week 8, but it will technically be week 9 from the syllabus. So if you guys do want to look ahead and see what topic we're going to go over, you guys can reference the syllabus for that. But you won't have anything to do next week, so you don't have to worry about that. And I'll see you guys 2 weeks from now then.